Good day, everyone. I'm here to present the study entitled Improving Rice Farming Productivity Through Solar Powered Electronic Steering with SMS Notifications. I'm Frylan G. Distresa from Batangas State University. My co authors are Dr. Luisa Juana Buenas and Engineer Alfredo B. Atienza, Jr. from Batangas uh, State University also. Rice is the second most widely grown food crop. The Philippines, the world's eighth largest rice producer with a total arable land of 4.5 million hectares. Rice is staple food for around 80% of the population, and it is the Philippines' most important crop. According to the World Bank in 2016, also from the World Agricultural Organization, there are at least 26.7% farmers globally, or 26.7% global working force are farmers. As we can see on your screen, from atlasbig.com, just recently, shows that more than half of the land area globally is producing rice, the one with the yellow touch color. And the Philippines, the small island there, is the eighth largest rice producer in the world, next to Thailand, and of course, the largest is China. And as I have said a while ago, 80% of the Philippines population is rooting for rice. Just recently, the Philippine Statistics Authority reported that there are 197,000 declines in the agricultural and forestry sectors. So, a great degradation in the workforce. The rice industry here in the Philippines faces challenges with the quality of production, labor, and energy shortages and health concerns for farmers and consumers. Farmers face challenges in drying paddy rice due to a lack of manpower and the labor intensive nature of the process. Inconsistent steering of paddy rice can also affect the quality of the grain. Drying paddy rice is crucial in harvesting rice and affects the quality of the grain. Drying can be done traditionally or mechanically, with sun drying being a common traditional method. The drying process of paddy rice is done by stirring and mixing every 30 minutes to 1 hour to ensure even drying. The process takes 1 to 2 days in sunny weather. The researchers focus much on the developmental part of the project. The diagram is more on theoretical framework than a literature review. So the literatures were categorized in four: hardware, software, network, and method. The biggest part of the diagram is the sensors. So we studied and reviewed more on sensors since we plan to make the project fully automated with a notification feature via short messaging services, or the SMS. We followed this engineering design process for the methodology. We identified the problem, which was stated in my introduction, make read lots of literature and many meetings after deciding and proceeding to building a prototype. The testing result will be shown later, which was after the working prototype was built. During the testing, we encountered some glitches and errors that needed to attend to. That is where the improved pace came in. Repeating the process until the project is fully created and tested, and here I am presenting the project. Showing the design of the prototype, and it was labeled accordingly, showing also the placement of the sensors. This page shows the photos of the actual project or the actual prototype. Now let's go to the testing and evaluation results. Testing the validity or calibrating the sensor, the HT11, for both the temperature and humidity, and comparing the result to the hygrometer tool available in the market. The graph shows that there is no difference made in the temperature values for both the HT11 and hygrometer. On the other hand, there is no much difference in the humidity for both except there is a glitch using the tool at the 8:20 a.m. That's the yellow one. The charging rate of the solar panel system in an actual setup or in the project resulted in an average 3.83% charging rate every 30 minutes intervals. Testing has setups A, B, and C, whereas set A starts at 8 a.m., where the temperature is 30.3 degrees. Set B starts at 11 a.m. with 32 degrees Celsius temperature, and set C starts at 3 p.m. with a temperature of 30 degrees Celsius. The initial state of the charge of the battery for all the setup is 40%. Testing the project and the actual steering of the paddy and was able to get the temperature and the duration of steering all the paddy rice, and it has resulted in an average of 4 minutes and 46 seconds. Means the project could steer the paddy rice in the testing area for 4 minutes and 46 seconds. The moisture content was tested and the graph shows the result. This is the result from the using the project. The blue graph shows the starting temperature of 28 degrees Celsius at 8 a.m. And as expected, the highest temperature is at 12 p.m. and ended at 20 degrees Celsius in 3:30 p.m. While the moisture content of the paddy rice was initially 28% at 8 a.m., the orange one, and was dried and resulting in a moisture content of 12% at 3:30 p.m. Simultaneously setting up the traditional and the actual implementation of the project, the group was able to capture the moisture content of both, having the same exposure to sunlight. The temperature was captured. As the line graph stated, there is very little significant difference between the two methods. The traditional is still the best method if properly executed. Nonetheless, the project is comparable. Computing the economical viability of the project and the table showing the needed data, the total cost of the project is 11,354 pesos and 75 centavos. The data acquired from the owners of the paddy rice, the payment for the traditional drying method is 10 pesos and 50 centavos per sack of paddy rice. So the researchers captured the highest number of sacks dried for the following months, shown on the screen. The total payment for paddy rice drying for month September, October, November, December, January, and February is 12,075 pesos. So computing it up using the total payment for rice paddy drying minus total cost equals to the total profit. So therefore, the the project has and the total price for the actual or the traditional paddy rice drying has a difference of 720.25 pesos in 6 months. So this is an example message from the project showing the alert message, and it reads, there is a possibility of rain. The barometer air pressure is relatively low. Thus, the notification feature is working properly. And to conclude, the components and tools needed in development of the project were identified and were able to use in the project. The air temperature and humidity sensors, that's the DHT11 of the project, have been tested and validated using the hygrometer. The actual charging rate of the solar panel of the project has been acquired, which is a 3.83% average charging rate. There is a little significant difference in terms of the moisture content between the traditional and the project methods and drying paddy rice. Nonetheless, the project is still comparable to traditional. And as computed a little later, return of investment in 5 months have been acquired. So once again, yours truly, Froilan G. Distresa from Batangas State University, the National Engineering University, Aras of Nasugbu Campus, saying thank you.